Now I'm going to show you a harder proof. Sometimes it's not as easy. That's another thing that was really hard as a student, is we would get problems presented in class because there's not enough time that were all easy, and then you go to do your homework and your problem doesn't fit that one. So it's not a monkey see, monkey do. Sometimes you have to use your brain. Step 1 is to find the limit using wits and intuition. And I can see that from this the limit is 2.5 or 5/2. Step 2 is to set up the inequality and work backwards. That's the scratch work that you don't show anybody. When I combine fractions, what happens is I get this ugly looking thing right here. I get this minus 41 over 8n plus 14. Ugh, that's not going to be fun to solve for n, and I'm not quite sure that it's going to give me anything useful. So I don't want to work with that. So what I'm going to do is I'm going to find something easier to work with that's bounding my original sequence above. So if my bottom got smaller, I would have an 8n here. If the bottom gets smaller, the whole fraction gets bigger. So this fraction here caps this fraction here. Now I'm going to set this upper bound less than epsilon. Instead of working with this thing, I'm going to do this thing. And I'm going to now solve for little n, just like before. Little n turns out to be bigger than 41 over 8 epsilon. I'm going to set capital N. That tells me what to set capital N as. It's the first positive integer bigger than 41 over 8 epsilon. All right. He who shall not be named, Dr. X. The proof where you can't know where anything actually came from. So this is the forward proof where none of the hard work is given to you, and you have no idea where anything came from, although you understand step by step what's going on in the proof. That was the whole point of a proof. You're arguing a point. I start out with let epsilon greater than 0 be given. Always. I will show that the limit of this sequence is 5/2. Let n be selected out in left field so that n is bigger than 41 over 8 over epsilon. If you didn't know where that came from, it really would look like something really from left field, wouldn't it? Then for n bigger than capital N, I have, now it's all my work, xn minus x is this guy over here, which is this guy over here by combining fractions. And I probably should have put a little arrow that says combining fractions yields. So I missed a step explaining all algebraic transformations on the checklist. And then I explain here that removing the 14 just makes the fraction larger. And since n is bigger than n, I've just made the whole fraction larger by replacing little n with capital N. And then, because I selected capital N to be bigger than 41 over 8 epsilon, 1 over n must be flipped both sides, the inequality turns around. And 41 over 8n must be less than 41 over 8. Look at that, everything cancels, and I get epsilon. So then what I have is that xn minus x is less than epsilon for as long as little n is bigger than the capital N that I've chosen. And it's here I put step function, right? It's a step function or ceiling function they call it. I think in computer science and programming we have ceiling functions. So the first integer larger than 41 over 8 epsilon. So because I've shown this, by definition of convergence, that sequence converges to 5/2. I remember actually having wondering how Dr. X got things to work out, so he got epsilon here. I didn't really know where that was coming from. And I've been asked that by students taking real analysis. Where did that come from? How did he know to do epsilon over 2 here? It comes from step 2. You work it backwards first, figure out what your cut point's going to be, and then you write the clean proof forward. So that completes the proof.